Hi everyone, it's week one. We're officially underway, and this is Instructor John with the first of what will be 16 videos. 16 not counting the 3 or 4 that I've already done and posted in week 0 to help you get started. But this week, as I'll do every week, I'm going to solve a problem from the textbook. A problem similar to, but not of course, not the same as the ones I've assigned, but similar, so you get an idea of what we're looking at, how to go about solving some of these problems. Just give you a little leg up in completing the assignment. So here's the one I'm going to do today. We're going to do assignment 14, found on page 14. It's the waiting time case, as I recall. And let me just check, make sure I've got that right. I'll go over here and look at the book. Yes, 14. Oh, it's a trash bag case. I'm sorry, trash bag case. Problem 14. Found on page 14. Okay, the first thing we're going to need is all this data stuff here. And just to review what I put in one of the week 0 videos, I'm going to go in and get the data. Where am I going here? We're in Excel. This window right here. I'm going to get it by way of the website rather than the student CD, which I don't have. Another good reason to do it this way. So let's go to, as I said earlier, I'll create a new tab here. And we'll go to McGraw-Hill-Higher-Education.com, MHHE/Bowerman, Bowerman, ESS4E. And we'll go to the student edition. We'll go to the data sets. And we'll look for I can't remember what I just said. Waiting time or trash bags? I get the two confused, obviously. A second. Trash bags. Okay. That'll be the last time we'll have to look for that. Trash bags. Here we are. Trash bags. Trash bags. There we are. Okay. I'm going to open it with Windows Explorer and double click on it to open it in a new Excel workbook. I'm going to select the data. There we go. I'm going to excuse me, copy it. Copy it. Go back to my workbook, which is here. No, it's not there. Here. And we'll paste it. There we have it. Now, there is a little runs plot in the book, you may have noticed. We're not going to use that. Let's create one of our own. Again, I'll select the data. This is the length of time a customer. I really want to do the wait time problem. This is the trash bag case. How many pounds can you put in this? Oh, for Pete's sake. How many pounds can you? Not get it right yet. How many pounds can you put in a trash bag before it breaks? And if you've ever taken the garbage out recently, as I did a couple nights ago, having a trash bag break is not a happy thing. So we're going to insert a line chart, and we'll put the little marks on it. And there it is. We've got a nice little runs plot to look at. A little bit bigger, and we'll get rid of this. What did I do here? Get rid of that. I think I made it too big. Yeah, let's get rid of this thing here. Really big, didn't I? I'll make it smaller again. Oh, I did that, but I did. Okay, we're getting there. I just keep dragging on the lower right hand corner to make it smaller. There we go. Now we can see it. Now, the book says in the very last sentence something that I think is significant. Earlier versions of this textbook made a bigger deal out of it. But let me just point something out. We go back here to the textbook, which is right here. It says, assume that the trash bag manufacturing process is operating consistently over time. Now, what does that mean, and why is that important? Well, if we go back to our picture here, we can see that we really don't know much about these samples except that there are, what, 40 of them. And we don't know when they were taken for sure. Maybe the textbook tells us. But let's say they were taken this week. Well, how do we know that the machine was working this way last week or a year ago? We're told that we can assume that it's operating consistently. And in fact, we look at the 40 samples and we see they don't, they vary up and down, but they're running around some average value. I don't know, if I were to guess, I'd just eyeball this and say somewhere between these two lines, which would be maybe 51 pounds. Now, it turns out in Excel, and this isn't part of this week's assignment, but I could ask Excel, what is the average value of all those data points? And we'll just see how close my 51 eyeball was. I type in the word average, I select the range of cells, I close the parentheses to make the function complete, and I hit the enter key, and of course there's the answer, 50.6. Well, I wasn't too far off. 50. That's the average value, and you can see most of the trash bag weight varies pretty consistently around that value. There's some that are higher and a roughly equal number that are lower, and that's good. That says the machine that's making this, the materials we're using in the trash bags must be fairly consistent. And if we saw that there was a trend, let's say the breaking level was going up rapidly or was declining, the average value was declining over time, that says something's going wrong here. Something's changing. We better find out. But if you want to make 1,000,000 trash bags, you want to know that they're all going to be pretty much the same. Now, why is there variation? Why doesn't every bag come out at 50.6? Well, obviously, the machine isn't exactly precisely the same from moment to moment. The materials that go in aren't the same. The temperature of the materials isn't necessarily the same. Maybe the relative humidity, the atmospheric pressure, who knows what variables there are. But each bag that is produced has a different strength. Okay, now what we're asked to do is to estimate the limits between which we can expect the breaking strength to fall. Now, this is not an easy question to answer because your definition of the reasonable range is different than mine, perhaps. I'm a pessimist. I say, look, I can see values that get down almost to 46 and some that get a little bit bigger than 54. My answer is going to be, I can feel really comfortable that the breaking strength is going to be somewhere between 46 and 55. Let me just insert some lines at those levels so we can see what we're talking about. And I'm going to go to Insert, Shape, and Align, and I'll draw that line. I'm holding down the Shift key. I'm going to click and drag across. Holding down the Shift key gives me a nice horizontal line without having to worry about whether I'm going up or down or not. I'd like it to be red, and I'd like the outline to be a little bit bigger, please. Let's make it maybe a 3 point. There, let's make it 3. There, that looks good. And I'm going to copy it and paste another one, so I have 2 of them. I'll put that down here at 46. That's where I think the limits ought to be. Now, you might say, there's just a few that are outside that range, and we could ignore those most of the time. Not all the time, but most of the time, we'll put the limits maybe right there. And I'll put the other limit maybe, we can go right there. So I'm going to say a smidgen over 52. Maybe I'd be comfortable at 52.75 on the high end. Oops, I did them backwards. And 47.75 on the low end. Now, who's right, who's wrong? Well, it just depends, and you have to accurately answer this question. You have to define what you mean by most, or how you've set the limits, what rule you've used to set the limits. Now, later on in the semester, we're going to Another way, wait a minute, before I say that, let me say that Excel could have an opinion too. We could ask Excel, what's the minimum value you expect? And the function is min. And again, I type in min, open parentheses, select the data. I close the parentheses, and the minimum value is 46.8, somewhere between those two. Obviously, there's a max equals max. I'm going to start at the bottom and work up. Why not? Nothing says I can't. I don't want to put the word strength in there. That might mess things up. Okay, 54. So again, it just depends on how you define it. Now, later on in the semester, what we're going to do is take data like this, and we'll calculate the average value, the 50.6 number. And then we're going to say, I want to have a confidence interval. I want to define a percentage, and so that I can say that I am 95% confident that all values I will observe, will fall within this range. And I can come up with a lower limit and upper limit and be 95% confident that all values will fall within that range. I could set the percentage to be anything I want, 99%, 60%, you name it. I'll tell you what the range is. And we use something called a standard deviation. Again, this is several weeks down the road, but that's why this problem is assigned this week, just to get us started to start thinking about this sort of thing. Okay, that's all I have for this week. Be sure to ask questions if it's not clear. If you're having problems navigating the site or using Excel or understanding what the textbook is saying, I really want you to ask. The best bet is to put an I don't get it question up so that you and your classmates can learn from the answers. And incidentally, if you see a question posted and I haven't answered it, dive right in and you answer it. I make my life easy. I'm all for that. And if not, I'll try to get out there and answer them as quickly as I can. If you want, send me an email. That doesn't earn any bonus points, but it's another way to do it. And if you, incidentally, if it's something personal like your grade or, your cat's sick this week and you can't get the assignment done or some other thing, send me an email. And if you're really stuck, you're really frustrated, I'd be glad to talk to you on the phone. Okay, that's all for this week. We'll see you online. So long.